Okay, welcome back, guys. Um, this is the setup for it. So this is using the right point as the pivot point. So we have 430 plus M, that's the upward force, and that's at 0.2 meters from the pivot point. That's trying to make it swing up. And then for the torque's trying to make it swing down, we have 430 grams at 0.1 meters from the end. And then the mass of the stick, the weight of the stick, at a half a meter out. So that's 0.5 M. Solve for M and you wind up with the same thing, 143.3 grams. But this is the setup for you, or something very close to it, equivalent to it. Okay, now we're going to move on to Planck problems. And again, the Planck problems are where you have a plank which is supported from 2 points. And there's different variations, but usually they boil down to how much weight is supported by each one of the supports. Okay, so I'm going to show you one that I have set up here. Yeah, there it is. Okay, so we have a stick, and this is the same stick that we used before. So by the way, we never did get to find out. We calculated that the weight of the stick was 143 grams through all these different ways. When we actually put it on the scale, it turns out to be 142 grams, which is pretty good for such a crude construction. The holes are not drilled precisely. The center of mass of the stick may not be exactly at the middle because it's wood. There's some variation. So we were off by 1 gram, and that's really, really good. But the actual weight of the stick was 142 grams. This is the setup as I just showed you here. You can visualize it. So we have scale A and scale B. We have 500 grams sitting 10 centimeters from the end. The scale is at 20 centimeters from the end. The center of mass of the stick is at the middle, as we know, and it's 142 grams. Scale B is at the 60 centimeter point, and then we have 200 grams out here at the ninth hole. And we want to figure out the weight on A and on B. Now, the way we approach this is to remember that the plank is in equilibrium. So that means that the torques are balanced, so there's no net twisting force, and the linear forces, the up and down, the weight versus the support forces, those are also in balance. So the net torque is 0, and the net force is also 0, and that's the key ideas that we're going to be using when we solve this. Okay, let's go back to here now. Okay, so for convenience, we're going to use this end of the stick as our reference point. We're going to pretend that that's where it would pivot if it could pivot. And again, we can use any point that we want as our imaginary pivot point because it's in equilibrium. We can make the assumption that it could swing from anywhere. We could just as easily use the other end. We can use one of the pivot points on the scale and have, torque this way versus torque this way relative to the scale. I personally find that it's easiest to use the end. I think you'll see why here in a moment. It keeps the positives and negatives constant. You can even use a point that's off the end of the stick. It'll work just fine. You literally can use anything. I find it convenient to use this one, so that's what we're going to go with. Now, the net torque has to be 0. So the torques going that way have to be equal to the torques that are trying to make it go this way. The vertical forces are also in equilibrium, so the support forces from A and B has to be equal to the force of gravity pulling the whole thing down. Okay, so let's see if we can define these here. Let's start off with, let's just dive into for some torques here. So first we're going to deal with the forces that are making it swing down. So these forces here, and we'll put these on the right side of the equation. So we have 500 times 0.1 meters, because that's how far the 500 grams is from the pivot point. The weight of the stick itself is also trying to make it swing down. So we have 142 times 0.5 meters. And then the third thing is the 200 grams over here, which is 0.9 meters from our reference point. So that is the right side of the equation, which is going to be all of the torques which are trying to bring it down. Okay, now what about the other side? Well, we have A is pushing upward, which is trying to make the thing swing up, and B is pushing upward, which is trying to make the thing swing up. So we need to know what they are. We know that A plus B, that's the vertical forces, have to be equal to the total weight of the contraption. So that is going to be equal to 500 plus 142, that's the stick, plus 200. That's up there. So that is equal to, you know I can't add and talk at the same time, 500 plus 142 plus 200, 842 grams. 8A plus B is 842 grams. And that means that B is equal to 842 minus A. All right, so we've rearranged this equation to solve it in terms of B. And B is 842 grams minus whatever A is. Okay, this is nice because this means that we only have one variable to worry about because we've expressed one variable in terms of the other. So now let's look at these two. We'll start with B because why not? So the torque produced by B is B times 0.6 meters. And then we're going to add to that A, and we know that A, oh boy, I messed that up. Okay. Bear with me here a little bit. A times 0.2 meters. I told you I couldn't think and write at the same time. Okay, so the torque produced by A is A times 0.2 meters because it's trying to make it go up. And the torque produced by B is 842 minus A, and that quantity is times 0.6 meters, okay? Because it's B times 0.6 meters. That's the lever arm. So this term for the torque caused by B is 842 minus A times 0.6 meters. All right, now this looks kind of complicated, but you'll find when you do these that they actually collapse down very quickly and very neatly. So the algebra on these is not nearly as bad as you might think. So first we break them all down, distribute everything so we have things in terms of A and B and straight numbers. And we wind up with 0.2A plus 842 times 0.6. So that is 505 minus 0.6A. All right, because we did 842 times 0.6 equals 50 plus 142 times 0.5 is 71 plus 180, which is 200 times 0.9. Okay, that's what it is. Now we break that down a little bit further and we get negative 0.4A because we have 0.2A minus 0.6A. So negative 0.4A is equal to 50 plus 71 plus 180 minus 505 equals negative 204. And if you put the numbers on this side and the A's on that side, they'd both be positive, but it comes out to the same thing. Anyway, go at negative 204. We divide that by 0.4, and we wind up with A is equal to 510 grams. We also know that B is 842 minus A. So B is equal to 842 minus 510. And we get 332 grams is equal to B. Super. Let's see if we're right. What this means, by the way, is that scale A will read 510, scale B will read 332. That's what we're thinking. All right, so let's see if we're right. Bring this back over here. Flip it right side up so we can see what we're doing. There we go. I need to pick this thing up so that I can turn on the scales. Want to warm up. I'm leaving the buffers on there because those are just, that's not part of the setup. That's just part of the scale, so we can be very precise about where we're setting these things down. And there we go. And we wind up with 513 and 331. So we got 513 and 331, and that's pretty good. Let's see. If you want to, you can run this through again and do it from this pivot point. Okay, so run the problem again and assume that it's pivoting around this one and see if you can set up the equation again, and you should come out with the same answers. Okay, I'm going to run through that one, and I may skip through it and just come to the solution because I'm not sure how we're doing on time. But that's something that might be worth doing if you want a little bit more practice. The homework problems that you're doing, by the way, are generally simpler than these ones. These are kind of the varsity ones, and the homework you do will be a little bit easier. AP exam will probably not have this style of problem, although they may ask you the concepts that go into it. That's totally fair game, although they probably will not have you crunch numbers like this on the actual AP exam. However, when you take physics in college, you're going to be doing these. So this is as good a time as any to learn them so that when you're exposed to them again in a year or two or three, it'll come back to you that much faster. Okay, so let's run through this with the run it from the other side. Pause it if you don't want to watch this. See if you can do it yourself, and then we'll walk you through it. All right, let's see what we can do here. We are going to do this one. So we'll do 200 times 0.9 plus 142 times 0.5. I'm sorry, that's times 0.1 plus 500 times 0.9, and that is equal to 0.8 times A plus 0.4 times 842 minus A. That's the setup. Okay, so this term is the first one. It is 0.1 meters from the pivot point. This one is the stick itself, half a meter from the pivot point. This one is the 500. It is 0.9 meters from the pivot point. This term is scale A, which is 0.8 meters from the pivot point, and it is what it is. And B is 0.4 meters from the pivot point, and it is equivalent to 842 minus A. Now we just distribute, so we get 0.8A plus 842 times 0.4, 336.8 minus 0.4A, and that is equal to 20 plus 71 plus 45, 450. Start combining these things, and we get 0.4A, because that's 0.8 minus 0.4, is equal to 20 plus 71 plus 450 minus 336.8, 204.2. Divide that by 0.4, and we get 510.5 grams for A. Same answer. Very reassuring. Physics works again. All right, thank you for your time. Good luck on the homework, and we will see you next time.